So we're going to switch gears a little bit here and talk about cannabis from an analytical perspective. Again, I'm M.Ravenelle. I work for Hamilton Company, specifically for the Robotics division. And the title of my talk today is Automated Workflows for the Cannabis Analytical Lab, Increasing Sample Throughput and Data Reliability. So I'm first going to just kind of introduce Hamilton. I promise this isn't a marketing-heavy presentation, just so you know who Hamilton is and what we do. We're a global enterprise, a global company. We were founded in the 1950s by Clark Hamilton. Our flagship product is our syringe. If you've ever done any kind of chromatography in your life, you probably know the Hamilton syringe. It's kind of our famous product. But since then, Hamilton has really grown. We provide a variety of analytical products and systems for the laboratory. We sell into a variety of different industries. We have robotics, as I mentioned, devices, consumables, customized solutions, and we also do OEM agreements. So we are original equipment manufacturers for a variety of companies out there. So what I'm really going to talk today about is our robotics division, and that's who I work for. And when you think Hamilton Robotics, what I really want you to think of are liquid handling solutions. So we really try to drive this home. The simplest way to explain it is if you are doing any kind of liquid handling in your assay or your workflow, you can probably benefit from our automation. So we're really talking about taking away the lab tech who's sitting there pipetting on a bench all day long and really putting that on a robot and freeing up that tech to do other things in your lab. So we have multiple sizes of instruments, multiple configurations. We are very integration friendly. So we integrate external devices, equipment from third-party providers, and integrate those into our platforms to really have an end-to-end solution for some of the things that are done in the assay lab. We also have on-deck tools and devices that we manufacture, in addition to integrating with third-party components. And we're kind of known in the industry for leading in service and support. And we have a lot of automation experience, not necessarily in the cannabis world. This is kind of a new application and a new market for us, but we do have a lot of automation experience in other related markets. So I'll get into the kind of the nuts and bolts of my presentation, and I'm going to talk about why we test cannabis and what's tested for in cannabis. And that may seem like a silly question to some, but I don't think anybody here, after all the talks we've heard this week, there's no question why we should test. You know, some of the concerns with cannabis, some of the concerns and challenges that are actually facing laboratories right now, and some of the opportunities that we think Hamilton Automation and automation in general can be a big help. And then I'm going to briefly go over some preliminary experimental results that we have, some data that's related to workflows that are specific to the cannabis testing laboratory, and wrap up with some conclusions. So I'm going to start off my presentation with some really bad examples. Product recalls are prevalent in many different industries. It seems like you can't open up the paper, at least with once a month, hearing about a product recall. But I highlighted two cases because I think these are relevant to the medicinal cannabis world. Specifically, this McNeil Consumer Healthcare. So if you don't remember this, in 2010, McNeil had a massive recall of children's over-the-counter medicine. This affected about 130 million bottles of medicine. And just to give you an idea of what was wrong with these products, I'm going to read the quote. So some of the products included in the recall may contain a higher concentration of active ingredient than specified. Others contain inactive ingredients that may not meet internal testing requirements. And others may contain tiny particles. Well, it turns out those tiny particles were actually metal shards from the equipment manufacturing line. And that's a big deal, especially when you're talking about children's medicine here. And the other case that I wanted to highlight is just from last year. You guys may have heard about this case in New Jersey, and it was a case that affected the state police department up there. So there was a lab technician there who obviously lost his job after this, but he allegedly faked results in a drug case and drawn into question 7,800 criminal cases on which he worked. So he's essentially accused of making up data. He was observed writing test results for suspected marijuana that was never tested. This is really bad. And And I don't mean this slide to really be a scare tactic and have everybody question everything that's on the market, but I think it's important to highlight that this does happen. This is a real phenomenon, and even in heavily regulated industries, so here we're talking about medicine, and we're talking about law enforcement, it happens. And so I think it's important to highlight that automation and laboratory practice are important tools that we can use to prevent things like this from happening. So quality control. All marijuana is not created equal. I think we all know that. That's been kind of beat to death during this conference, but it's important to keep in mind, right? So Dr. Meary had a great talk. There's been other great talks here that really highlight that what's in your cannabis strain, the active components, makes a huge difference on the condition you're trying to treat and the effects that the individual is going to feel. So, you're not going to take a pill, at least probably most of us here wouldn't, take a pill which you had no idea what was in it. And so it's important to have quality data out there that consumers can trust. And the other flip side of it is it's important to know what's in your cannabis, but it's also important to know what's not in your cannabis. So I feel bad for this guy right here. He's kind of synonymous now with pesticides and cannabis. He's the first picture that comes up when you Google search cannabis and pesticides. So I blanked out his face there to give him a little bit of anonymity, and I feel bad for him because, it's not really his fault. He's the case of using the wrong pesticides in cannabis. It's an education issue. It's a lack of oversight issue. So you guys may have heard in 2005, Colorado actually withheld up to 60,000 plants for pesticide contamination, and the pesticide that was implicated there was called myclobutanil. And what happens is this is a pesticide that's used for normal agricultural products, everyday products that we consume. But when it's exposed to heat, it forms hydrogen cyanide gas. And if there's something you don't want to be smoking, it's hydrogen cyanide gas. So again, it's kind of a knowledge and an experience thing, and it's a real problem out there. And so why kind of are some of these problems, and what kind of issues does a lab have to deal with? Well, it's always a balancing act from the analytical perspective, right? You have, on one side, you have producers and growers who have expectations. They want cheap tests, they want accurate tests, and they want fast tests. They don't want product locked up or being essentially burned or destroyed because it fails tests, and they don't want their product sitting around waiting for results so that they can sell it, and that makes sense. On the other hand, you have consumers, and they care about product safety. They care about quality ingredients. They care about getting the proper medicine for the condition that they have. So it's really, how do you, as an analytical laboratory, kind of balance these needs? And I think that automation, in general, is a very good tool that we can use to kind of satisfy these. So there's good news. A little bit of myth busting is that nothing that's being done in these labs is new, and it's kind of interesting. I think since this industry grew literally out of garages and basements, and it's been underground for so long, that there's still kind of a lot of tribal knowledge, even in the laboratory setting out there, and a lot of kind of belief that they're unique and that the things they're doing have never been done before. But that's absolutely not true. All the things that are being done in the analytical lab for cannabis is all stuff that has been used for a long time and is very well established. Yes, the application's new, but the methods are out there. They're using liquid and gas chromatography, mass spectrometry, microbial contamination measurement whether via PCR or plating out and doing colony counts. I mean, this is not new stuff, and I think this is good news for the cannabis industry. There's a lot of technology and a lot of knowledge out there related to the food, agriculture, and consumer product safety testing markets, drug discovery markets. The information's out there. So what is usually done at a cannabis facility when they're doing testing? Well, It depends on what state you live in. Unfortunately, the regulations fluctuate quite wildly depending on where you are geographically in the country. But let's look at some of the common panels that are done. So moisture content, potency analysis, terpene analysis, foreign matter inspections, microbial screening, mycotoxin screening, which mycotoxin is mold, residual solvent if it happens to be an extract or a shatter. You don't want to probably be smoking an extract that has a lot of butane left over in it, for example. So this is important to look at. Heavy metal screening is another one, and that heavily relies on the type of fertilizer and the growing conditions that the plants are in, because they're very good at soaking up what's in the soil around them. And also, as I've already mentioned, the pesticide residue analysis. So the ones I have highlighted in green are really amenable to automation. I'm going to talk a little bit more about that. So let's look at the protocols that are done in a typical potency analysis or a pesticide analysis. Well, the workflows are very similar. The steps that are used are things that are used in industries all over. You're going to be grinding samples, homogenizing samples, adding extraction solvents, vortexing and mixing your samples in your extraction protocol, probably doing some kind of separation, whether it's a filtration or doing a solid phase extraction, extracting your analyte of interest, and then doing an analysis. So these are common things, and these are things that Hamilton has a lot of experience automating. And I'm going to talk specifically kind of about separation and cleanup or solid phase extraction that's used in pesticide analysis. So we have some results here, some quick data. It's very very brief, but it kind of shows, it gives you guys a flavor for what we do and some of the solutions that we have that are applicable to this market. So in separations, we did a quick study here comparing 3 different sample matrices. It's flower, edible, and concentrate, and this is done with one of our partners in California, a very reputable lab there. So this is using a device that we have, a nifty little device called our MPE squared. It's a horrible acronym. I'm not going to tell you what it stands for, but it's basically just a positive pressure extraction module. And what you're able to do with this module, as you can see in the little cartoon there, is input a filter plate, for example, a 96 well filter plate, pull that into the unit, have a collection plate underneath, and apply pressurized gas, and you can basically do a one-shot filtration of 96 samples. So if you've ever done hand filtration in a lab, like for example a syringe filter, you know it's a huge pain. I mean, you got to put a sample in a syringe. It's usually a Luer lock filter. You got to push it through manually. It's kind of a pain. So when you have something like this, you can do a full plate in one shot. So we looked at a comparison between that traditional manual filtration with the syringe and some samples that we filtered on our unit and compared them. So this is a table showing the results here. The thing to take away is if you compare the mean values that we measured for the analytes with the manual method compared to the MPE squared, we typically had higher mean values that we were measuring. We don't really know why this is, but it's a trend that we consistently noticed. And if you look at the standard deviation as a percentage of the mean, you can see that we had a better standard deviation, which at the end of the day means your data is more reproducible and more reliable. Other things to highlight from the study are savings on consumables and time. So this lab happened to tell us that they probably saved at least 30 seconds per sample going with the automated method, and 40% on consumables going with the plate, and a lot less waste generation, for example, and a lot less manual intervention. Another highlight of this unit that we've used it for solid phase extraction or a cleanup step in pesticide analysis. So typically when you're doing a pesticide analysis, you add your sample, some kind of internal standard, water, you're adding in some kind of extraction solvent, some salts to promote separation. You spin it down or do a separation step, and then you take that supernatant, and that supernatant has to be cleaned up again. So typically what happens is that supernatant goes into a tube manually with some resin. You shake it, vortex it, mix it, spin it down again, transfer that into your machine for analysis. Well, in this case, we ran that normal standard method, and then we just took a plate that had the cleanup resin in it, directly transferred the supernatant sample into there, pushed it through in our device, and went straight to the analytical machine. And so here's, again, a table summarizing the results. One thing to note is the pesticide recovery was significantly lower with the automated method, and we think there's things that can be done to increase that, but overall not bad. We have the recovery there, and depending on what state you're in, right, how they set their limit, how they regulate pesticides, the recovery may not be a huge issue, and there's things you can do to correct for that, for example, with internal standards. But one thing to highlight about this is the savings on prep time, about an hour over 96 samples. And I know this doesn't sound like much to people, but we'll talk about how sample throughput's likely going to increase here very soon for a lot of these labs. There's other options that we have on our instruments, and people are unaware of these, so I just thought I'd kind of throw them out there. There's companies, our collaborators, called DPX Technologies, that actually offers pipette tips that have resin pre-packed in the tips. So you can do extractions in the pipette tip. You don't even have to use other sources of labware. You basically pipette it into the tip, and you can do some mixing in the tip and do a cleanup, for example, just right there in the tip. So these are huge time savers. These are cost savers, and they eliminate a lot of manual intervention in a lot of these workflows. And then genomics, we've heard some awesome talks here about really the power of genomics and how that's going to increase and how that's going to actually take to the next level, I think, cannabis as a medicinal product, when you can dial in strains that are going to be exactly what you need to treat your symptoms. So we've worked with medicinal genomics and also Cortigen, on automating some of their kits, having their kits available on our platforms to really just, at the end of the day, you load up your samples on the robot and you click go, and you can do some of these genetic profiling, microbial contamination tests, plant sex, strain identification, really walk-away solutions. So I'm going to wrap up here by kind of putting it all together. So the point of automation is, really there's a couple points to make. The speed and accuracy definitely are things to think about from a laboratory perspective. Plan for demand growth, because I'll just give you an example. In the state of California right now, it's estimated that at probably like 5 to 6% of the cannabis samples are actually tested in labs. Well, in 2018, 8 months from now, that's going to be mandated 100%. So that's a 20-fold increase in sample throughput, and it's going to be very difficult to handle. The point is, automation has to be in the labs, and I think it's very important for labs to consider it now, where maybe not necessarily they don't have the sample throughput, but they're going to be hit with it soon. And you want to be familiar with the automation aspect of it now, before you have 4,000 samples backlogged and you have people screaming at you from every end. And really, some of the things that I talked about, the dry labbing, things like that, the scandals. When you have automation, you have data tracking, you have validation, you have things that protect consumers at the end of the day to prevent things like that from happening. If you can go back and have a data trail, an audit trail to show that things were actually tested, I mean, you can't fight, you can't fake that. And reproducibility is key in this industry, and we're going to see a huge demand, I think, in the near future. So Hamilton's here. We have the experience, and just wanted to let you guys know kind of who we are and what we do. And just end with a quote that I think really aligns nicely from Joycelyn Elders, who's former Surgeon General of the U.S. This is from 2007. You've probably read this. The evidence is overwhelming that marijuana can relieve certain types of pain, nausea, vomiting, other symptoms caused by such illnesses as MS, cancer, AIDS, or harsh drugs sometimes used to treat them. It's the same theme of the conference. We know it works. We know it's very efficient in treating a lot of things out there, and ultimately Hamilton is aligned with the cause. We're concerned about consumer safety. We're here to push science forward, so if we can be a part of this whole movement, we're here. So thank you.